This is section 3.3, properties of logarithms. The I can statements for this section: I can apply properties of logarithms, and I can apply the change of base formula. So the properties of logarithms, we have a product, quotient, and power property. The product property says if I have a log base b of x times y, we can expand this and say log base b of x plus log base b of y. So anytime you see multiplication, you can break that up and make it addition. The quotient property of log base b of x divided by y, instead of division, when you expand this, it becomes subtraction. So it's going to be the log base b of x minus the log base b of y. And if you have a power property, log base b of x to the p power, you can take that power, or that exponent, and you can bring it out in front. So it's just p times the log base b of x. So this is how you can expand, and later how we'll reverse it and we will condense logarithmic functions. So we want to express each of these logarithms in terms of the ln of 2 and the ln of 3. So first we need to break down 54. 54 is 6 times 9. 6 is 2 times 3, and 9 is 3 times 3. So we can rewrite this as the ln of 2 times 3 to the third, because 2 times 3 to the third will get us back to 54. Now from the properties we just looked at, we know we can change multiplication into addition. We can expand it. So to expand this, to get the ln separate, when you get multiplication, you turn it to addition. And when you have an exponent, we can bring that out front of that log. So now we have ln of 2 is equal to 3 times the ln of 3. So this ln of 54 is now written in terms of ln of 2 and ln of 3. If we do the same thing on the next one, 9 is 3 times 3. 8 is 2 times 2 times 2. Or we can rewrite that as ln of 3 squared over the ln of 2 cubed. Remember, division can change into subtraction when we separate. I'm sorry, there's not an ln on top and bottom. The ln is just out front. That looks a little better. And when we change this to break up the ln's, we will change it to subtraction. So this is the ln of 3 squared minus ln of 2 cubed. To get rid of those exponents, we bring them out front. This is going to be 2 ln of 3 minus 3 ln of 2. Okay, on these ones, we're just going to evaluate the logarithm. So we're going to rewrite them so we can actually solve them. So on the first one, we do need to get rid of the fifth root. Remember, the fifth root is the same thing as something raised to the 1/5 power. Now, since we have log base 4, we do want to see if we can get the 64 to be a 4. And if we break 64 down, 64 is just equal to 4 times 4 times 4, or 4 to the third power. Now when we're dealing with exponents, when you have a power raised to a power, you multiply. So 3 times 1/5 will give us 3/5. Now if you remember back to section 3.4, if you have a log base 4 of 4, those will just cancel and you're just left with your exponent. So this will just equal 3/5. On the next one, we can simplify this by getting the exponents out front first. So remember, you multiply. Two times 5 gives us 10. So we have 10 times the ln of e minus 3 times the ln of e. The ln of e is the natural log, so log base e of e, and that's going to cancel and just give us 1. So 10 minus 3 will give us 7. So the answer for part B is 7. The next thing we're going to do is we're going to expand expressions. Remember, multiplication, when you expand it, turns to addition, division turns into subtraction, and exponents get multiplied out front. So on the first one, let's make our multiplication into addition first. Now any exponents, you multiply in front of that log. So our expression expanded will just be log 12 plus 5 log of x minus 2 log of y. On the next one, we're going to start by getting rid of that division. Remember, when you split it up, it becomes subtraction. Now, a square root is the same thing as raising something to the 1/2 power. Now, since these are both raised to a power, we can just bring the powers up front and multiply them. And we're left with 2 times the ln of x minus 1/2 times the ln of 4x plus 1. And you do need to make sure you keep those parentheses around the 4x plus 1. Now we can actually work this backwards and we can condense expressions. So the first thing we do when you do condensing is the opposite of what we did when we expanded. So we're going to bring the powers out front, back up to the exponents. Now we have subtraction. Subtraction turns into division. We don't like to keep fractions in our expressions if we can get rid of them in the exponent. So remember, the same 1/3 is the same thing as the third root. So our expression condensed will just be the log base 3 of x to the 4th over the cube root of x plus 6. On the next one, we're going to get rid of our exponents first again. Sorry, we're not getting rid of the exponents, we're bringing them back. Remember, the multiplication up front does come back as your exponent when we are condensing. And addition changes to multiplication. So we're just left with x minus 6 to the 6th power times x to the 3rd. Now on your calculator, you can only calculate logs if it's log base 10 and log base e. So you can only use the common log and the natural log. But they don't always give us numbers that show up like that. And if they aren't something you can break down to make them so they're the same number as the base, like when we had log base 3 of 3 to the 4th, log base 3 of 3 would cancel, will leave you a 4. So if we can't find something that works out nicely in that form, we are going to use the change of base formula. And to do this, we're going to say the log base b of x we're going to change that and we're going to do log base a of x over the log base a of b, where you get to pick your log base a, where you would usually pick either your common log, which is log base 10, or your natural log, log base e, or the ln, so that you can just plug this into your calculator and find the value. So to try the change of base formula, we have log base 3 of 5. So this is your b value. This is your x value. 5 definitely is going to break into 3 to raise to any power, so we can't calculate this until we change the base. So we do log base a. In this case, let's just do log base 10, or log itself on the calculator, of your x value, so log of 5, over the log of 3. Now you can just put log of 5 and log of 3 directly into your calculator, and if we do log of 5 divided by the log of 3, you're going to get approximately 1.47. Do the same thing on the next one. We're going to do log base a of x over log base a of b. And if you put that in your calculator, you're going to get approximately negative 2.58. On the last one, log base a of x over log base a of b. And we plug that in, we're going to get approximately 1.916.